homework. Okay, so number 16 on the homework. Remember, solving by factoring means you need to set it equal to 0. So subtract 192. Now you have 81x cubed minus 192 equals 0. Okay? So 81x cubed minus 192, well, you know what? Those are pretty big numbers. There must be a GCF, maybe, right? So 81 and 192, just to make sure that I get the right GCF, I'm going to go, yep, it is 3. But in case you need to have another way to do this, go to math number GCD, put in 81, 192, and you get 3. Okay? So 3 is your GCF. Alright, so then I need to take 3 out. So that means we're dividing everything by 3. And then we get 27. Okay, 27x cubed minus 64, right? Equals 0. Okay. So now, we're going to wait on this 3, okay? And let's look at this 27x cubed minus 64, and let's factor that out, okay? So this, we need to use that self way. 27 is a perfect cube, x cubed is a perfect cube, and 64 is also a perfect cube. So this is going to follow that 2 and 3, right? I'm going to bring the 3 down here. What is the cube root of 27x cubed? 3x, good. What is the cube root of 64? 4. The first one, you square the first, so it's 9x squared. In the middle, you multiply these two, so it's 12x. And the last one, you square this, so you get 16, right? Now for your sign, same, so it has to be minus. Opposite, always plus. Yes? Okay. So now, remember how we told you with the SOAP way, this trinomial, you can't factor it anymore. And if you want to solve it, you have to either use completing the square or the quadratic formula. Okay? So now that I can't factor anymore, I need to set each of these factors equal to 0. Do my mini equations. So this guy equal to 0. 3x minus 4 equal to 0. And then 9x squared plus 12x plus 16 equal to 0. Okay? Does 3 equal 0? No. And there's no variable there. So you know what? Throw that one away. You don't need it. How about this 3x minus 4 equals 0? X equals 4/3 here. Okay? Alright? So now that one, the 9x squared plus 12x plus 16 equals 0. Well, I'm just going to put this over here. Okay. Which one do you want to do? Quadratic formula or completing the square? You want to do completing the square? With this one? You know what? Yeah, I'll do the completing the square with the other one. This one's going to be too ugly. Okay. Let's use the quadratic formula. Let's do A equals, B equals, and C equals, right? Okay, so the quadratic formula is x equals opposite B plus or minus the square root of B squared minus 4AC all over 2A. Okay? So x equals, let's see, negative 12 plus or minus, what goes inside the square root? Because we got to do this first, right? What is that? What is our discriminant? Negative 432. Is that right? Okay. All over 4, 2 times 19, or 2 times 9, which is 18. Right? Okay, so now I have x equals, let's simplify this first fraction. 3, 4, 6. Oh my gosh, I could have done bigger, didn't I? Okay, plus or minus. I need to simplify this radical, just for the sake of time. If I simplify this radical here, negative 432, I have to bring out an I. This is 2 to the 4th times 3 cubed. 12I root 3. Do you guys need me to simplify this radical, or are you guys okay with that? You're okay? All right. So we need to bring an I out, right? Because it's a negative inside. And if I simplify this down, it becomes 12I root 3 all over 18. Okay? So then now I need to simplify those two numbers, right? So then I have x equals negative 2/3 plus or minus 2I root 3 over 3. Okay? Yeah? So then here's another one. So I have 1 positive and a negative, so 2, 3. I have 3 solutions. Yeah? 4/3, and I have negative 2/3 plus or minus 2I root 3 over 3. Since they have the same denominator, I could have combined them, but it doesn't matter. Am I supposed to have 3 solutions? Yes, because my degree, or my biggest exponent, is 3. Yeah? Okay, let's try the next one. All right, let's look at 15. So 15, solving by factoring, is not equal to 0, so let's make it equal to 0. You know what, I'm going to subtract 6. 0 equals x squared minus 6. Oh no, I shouldn't have done that. I should have done it the other way. I'm sorry. I know, I'm like in a rush, I'm panicking. X to the 6 minus x squared equals 0, right? You know, not that it would have been wrong to do it the other way, but you want your biggest exponent term, like your leading term, to be a positive. Because then you have to like GCF out the negative, and it's just more work. So now that you have x to the 6 minus x squared, GCF. What is the GCF here?
X squared.
Yeah, x squared. So then you have x to the 4th minus 1 equals 0, right? So x to the 4th minus 1, this guy right here is a dose, right? Because you have an even exponent, which you could divide by 2, and that's square root it, and square root of 1 is 1. So if I dose this, I get x squared plus 1 and x squared minus 1. Yeah? Don't forget to bring down your x squared from before, and all of this is equal to 0. Okay? You could solve it here because you know how to solve using the square root method. But since we're factoring, why don't we just factor everything through? Isn't this guy another dose? Yeah. X plus 1 and x minus 1. And then bring down this one, x squared plus 1, and bring down this x squared. Okay? All of that equal to 0. Alright? There's a lot, isn't it? So then now everything gets its own little mini equation. So you have x squared equals 0. You have x squared plus 1 equals 0. And this guy, x plus 1 equals 0, well, that's going to be x equals negative 1, right? And this one's going to be x equals a positive 1. Yeah.
Well, I feel about it.
Okay. So x squared equals 0. Well, to get rid of the square, what do I need to do? Square root. But when we draw the square root, we have to put what? Plus or minus. All right. So now I have x equals plus or minus 0. But there really isn't a thing as plus or minus 0, right? This just tells me it came from an x squared. It came from a power of 2. So we actually have 2 zeros here. That's what that means. Okay? So call this a double root. All right? And this guy, minus the 1, and we get x squared equals negative 1. Like you guys said, you get rid of the square by taking the square root, plus or minus. X equals plus or minus. Guys, what is the square root of negative 1? I. So now I have 1, 2, 3, 4. 4 solutions so far, right? 5, 6. Yeah? And then that's it. I mean, you can clean this up and put it in a solution set. Say, okay, 0 with a double root, because there were 2 of them there, plus or minus I, and then plus or minus 1. Yeah? So then there's your 6, there are your 6 solutions. Okay? All right, so this one. Okay. X to the 4th minus 10x squared plus 9. Okay. AM, because it's a trinomial, right? 2 numbers that multiply to give me 9 and adds to give me negative 10. Well, then that has to be negative 9 and negative 1, right? That gives me negative 10. So since this is an x to the 4th with an x squared, I would do the grouping way. Bring down the first, bring down the last. Rewrite the middle one, your x squared, using the 2 numbers that you have. So minus 1x squared minus 9x squared. Yeah? Divide it right down the middle. GCF is x squared, negative 9, x squared minus 1. So this is interesting, and all of this is equal to f of x, which is equal to 0, right? You have x squared minus 1, and you have x squared minus 9. Yeah? Both of those are what? Dose. So you could do that, right? X plus 1, x minus 1. X squared minus 9 gives you what? Uh-huh. And all of that equal to 0? Well, then look, now it's just so much easier for you guys to do your mini equations and solve for everything. X equals negative 1. X equals 1. Negative 3. X equals 3. Yes? So x equals plus or minus 3, plus or minus 1. And you have 4 solutions, which you should, because your degree is 4 in your problem. Yeah? Okay. All right. So this one's another SOAP, right? 125 and 216, those are both perfect cubes, and x cubed is a perfect cube. So this, what's the cube root of 125 x cubed? Good. What's the cube root of 216? The first one, right? So 1, 2, 3. First one would be 25x squared, then 30x, and then 36. Yes? Same. opposite, always plus. Okay? If you just didn't get these answers because you skipped it, because you didn't want to do the quadratic formula or the completing the square, you have to, okay? If you just didn't know how to solve this one, the trinomial, well then, I hope you understand that now you have to use the quadratic formula or completing the square with that one, okay? All right, so it's time for lunch. Are you guys okay with the homework problems then? Okay, all right. Have a nice lunch. See you soon. Okay, so let's look at the notes for today. All right, put your phones away. Okay, so we're going to look at solving or finding the zeros of polynomials using synthetic division. This is a combination of graphing using your calculator and using synthetic division and factoring square roots or the quadratic formula or completing the square. Okay, so this is basically going to tie in everything that you've learned together. All right. If you cannot factor, okay, if you see the problem and you can't factor it right away, then you have to graph it. You have to use synthetic division to reduce the polynomial by 1 degree. Okay? So if it started off being an x to the 5th, when you use synthetic division, it's going to bring it down to x to the 4th. You're going to be using synthetic division with the zeros, so your remainder must always be 0. If it is not, you make a mistake. Repeat your steps 1 and 2. You can repeat the synthetic division as many, as many times as you have zeros from your graph. Okay? But do that until you get a quadratic. What does it mean to have a quadratic?
For the exponents we do.
Well, that would be standard form, but quadratic means that your biggest exponent or your degree is 2. All right? So get it down to x squared or, whatever squared. Okay? And once you have a quadratic, this is when you use one of the methods that you know, the quadratic formula, completing the square, or factoring in order to find the rest of your zeros. Okay? All right, so let's try a problem here. Okay, it says find all the zeros of each of the following examples using synthetic division. So sometimes they may give you a 0. Here they said a 0 is 1. Okay. So that tells me I'm going to use synthetic division to bring this down. So what you want to do with these guys is let's keep a little solutions box or something off to the side somewhere so you can keep track of all of your zeros, okay? We should have 3 because my degree is 3. I should have 3 zeros, yeah? So one of my zeros is 1. Okay. So I'm using synthetic division. So I have x cubed. What's after x cubed? Like what's 1 below that? Yeah, x squared. But I don't have an x squared in my original, right? So I have to put 0 x squared. What's after x squared? X. So 0x and then minus 1, because that's my constant, right? And you guys did really well on the quiz on the division, so. All right, I'm going to take my 0, my 1, I'm going to do this, do my synthetic division. So that's a 1, 0, 0, negative 1. Bring down the first, multiply, add, multiply, add, multiply, add. Your remainder must equal 0 because this is a 0, all right? So remember what we said before, this is your remainder, that's your constant, this is x, and that's x squared, okay? Please make sure that you're paying attention to this. All right, so now I'm going to take this expression here, which is x squared plus x plus 1, and make it equal to 0, because that's how I'm going to find the zeros. And then what do I do with this? Can I factor this? No. Okay. You can try to AM factor it, but two numbers that multiply to give you 1 and add to give you 1, there are none. All right? So, Okay, so this, you can use the quadratic formula or completing the square. Okay? All right. So we talked about completing the square earlier. Let's do completing the square here then. Subtract the 1. We'll make it x squared plus x equals -1. Remember, with completing the square, we want to take our b. Our b number is 1, right? b divided by 2, right? Square it equals what? 1/4. So I have x squared plus x plus 1/4 equals, what's -1 plus 1/4? Yeah, -3/4.
And where did you get one? 1/2.
Oh, because it's b divided by 2, and then you square it. So your b number here is 1, right? So 1 divided by 2 gives me 1/2.
Why did you do that?
Oh, because that's part of doing the completing the square. You have to take your b and you have to divide it by 2. Okay. All right, and then so on this side I also added 1/4 as well. And that's how I got -3/4. Okay, so then now this trinomial on the left, I need to turn it into like a factor square, right? Factor squared equals -3/4. I know I have x. What goes in there? Well, it's your b divided by 2. My b divided by 2 is 1/2, so that's plus 1/2. Okay? Now, we can solve for this x. How do I get rid of the square? Square root, yep. And when we draw the square root, we have to put plus or minus. So then we have x plus 1/2 equals plus or minus, right? I know an I comes out. And you know what, guys? I know it's weird when we have a fraction inside the square root. So if it's weird, separate it. I comes out, and then we have square root of 3 over square root of 4. It's the same thing. But I think it makes it a little bit easier to simplify when you separate the square root for both of them. Okay? So now if I look at this guy, square root of 4, what is the square root of 4? 2. All right. So then this is x plus 1/2 equals plus or minus I root 3, and down the bottom it's no longer square root of 4, but now it's just 2. Does that make sense? Okay. So I'm almost done. but I haven't quite solved for x yet. In order to get the x all by itself, I'm going to subtract 1/2, subtract 1/2 on the other side. Okay. But here's the thing, when you add or subtract something, and that other side already has a plus or a minus, then this has to go in front of it. Okay? So you have x equals negative 1/2 plus or minus I root 3 over 2. Okay? And again, these have the same denominator, so you could just combine those, but I mean, it doesn't really matter. Okay? All right? So if I go back up to my solutions box there, that I was setting up earlier, I can put this one in too. So negative 1/2 plus or minus I root 3 over 2. Yeah? The 1 is from here. They already gave you the 0. So how many solutions do I have there? 3. 1, 1 plus, 1 minus, so that's 3. And that matches my degree. So I found all my zeros. Does this make sense? Okay. It's a lot of work. You have to keep it organized, okay? All right, let's try another one. Okay, let's try this one. So this one looks a little crazy, but it's fine. They give you another 0. All right? Okay, so a 0 here is negative 3. So I'm going to draw my little solution set somewhere. I'm going to put negative 3. Okay. I'm going to check and see if I have all of my terms and if every spot is filled, because I need to do synthetic division. So 4, 3, 2, 1, constant. Good. Every single term is there. So negative 3. 1, 2, negative 1, 4, and negative 6. Right? I'm doing synthetic division. Bring down the first, multiply, add, multiply, add, multiply, add, multiply, add, and it should be 0, yes? And then I'm going to fill this in because, I mean, we have to, okay? So we start with the remainder, then the constant, x, x squared, x cubed. Yeah? So let's write this out. And that equals 0. Remember, we're finding the zeros. So every time you get a new polynomial from synthetic division, it has to equal 0. Okay? Now look at this one. I realize it's not a quadratic. And we said, guys, wait until it's a quadratic before you do anything, right? But if you look at this, there are 1, 2, 3, 4 terms. Do you know how to factor if there are 4 terms? Yeah? How do you factor? Yeah, you split it, right? So, I mean, see if you can factor this. I think factoring is always the best way to, see if you can solve it. Okay, let's see if it works. GCF on the left-hand side is x squared. So if I divide everything by x squared, I get x minus 1. The GCF on the right-hand side is what? 2. So then if I divide everything by 2, I get x minus 1. Oh, this worked, right? I knew this would work because it was 1, 1, 2, 2. Right? So I have x minus 1, and I have x squared plus 2 equals 0, right? And then look at that. I can just go straight into my mini equations because I can solve for these x's, yeah? Because that is your end goal. Your goal is to solve for all of the x's. So x minus 1 equals 0, x equals what? 1. Okay, so here's one of them. I'm going to put 1 over here. And then the x squared plus 2. X squared plus 2 equals 0. Well, I know how to use the square root method. Right? Subtract the 2. Then I have x squared equals negative 2. Square root. Please don't forget, when you draw the square root, you have to put plus or minus. So x equals plus or minus I, thank you. When there's a negative inside that square root, an I has to come out. And then square root 2. Can I simplify that square root of 2? No, it's already a prime number, right? So you're good. So then your last two zeros are plus or minus I root 2. Well, let's go and put it over here. So how many solutions or how many zeros do I have in my solution set? 4. Does that match my degree? Yes. 1, 2, 3, and 4. Good. So I found all of my zeros. Yeah, do you have a question? Yul? No? No question? Okay. Any questions about this? Yeah?
With the x squared plus 2,
Uh-huh.
you wouldn't do those?
No. Because first of all, it's not a difference. And the square root of 2 is not, it doesn't give you a nice pretty number. That's an irrational number. Okay? All right, so let's try one where they don't give us a 0 right away. Okay? So the next one. Well, the next one, I'm looking at it, I go 1, 2, 3, 4. It's 4 terms. Maybe I can factor it. Don't write this down. I want you to see, just watch me do it. You can't factor it, but I want you to see why, okay? So don't write this down, okay? I want you to waste your space there. When you try, this is what you get. And you did it right, but how do you know that this is not going to factor? Parentheses are not the same. Okay, well then that's fine. Can't factor it. So what did it say in your notes? If you can't factor, you need to do what? Graph it. Good. So let's graph it. Put it in your calculator. Go into y equals, and let's graph this. Oh no. Plus plus. Okay. All right. So when you graph this, if your screen looks a little bit funny, then just hit zoom 6. Okay, that's all I see. Is that all you see? Okay, that's okay. What are we looking for? We're just looking for pretty zeros, okay? Zeros that go straight through. I don't want any decimals, I just want integers, right? This looks like it goes right through at what number? -3. Okay, so I'm going to go to second graph. Go to -3. Is it a 0? Yes, because your y number is a 0. This is an x-intercept, right? So there we go. We just gave ourselves a 0, -3. Okay, so I'm going to make my little solution set box. I'm going to say -3. What do we do with the 0? Synthetic division. Are all of my terms here? Let's see. 3, 2, 1, constant. Good. 1, 1, -1, and 15. Let's do synthetic division with our -3. Your remainder should always be 0 if you're using the 0. Okay? So I have x squared minus 2x plus 5 equals 0. Is this what you have? Shall I wait a little bit? Are we good? Can I factor this? Two numbers that multiply to give me 5, but will add to give me -2? You can't. Because 5 is a prime number, and the only two numbers that multiply to give you 5 are 1 and 5. Right? There's no way you can get 2 from that. Okay. So that tells me, okay, I can't factor it, then I have to use completing the square or the quadratic formula. Which one would you guys like to do? Quadratic? All right, quadratic formula. A equals 1, B is -2, and C is 5. No, I'm going to start over here. X equals opposite B. So opposite of -2 would be +2, plus or minus square root of b squared minus 4ac all over 2a. Right? And what I'm going to do is I'm going to do this first. I'm going to find the discriminant. And the good thing about finding the discriminant is that it'll tell me what kind of solutions I should be looking for. 2 real, 2 imaginary, or 1 real, right? What is that? 4 minus 20, -16. Yeah? Okay. All over 2, so divide each of these by 2. So, if my discriminant is a negative number, what does that tell me about the number and type of solutions that I'm going to have? Huh? A negative. 2, what kind? Yeah, right? 2 imaginary or complex. Okay. X equals 2 over 2 is what? 1 plus or minus, you know what? Let's do this. Let's simplify this guy. What's the square root of -16? 4i. 4i divided by 2. Now the 4i over 2, I can simplify those two numbers. What's 4 over 2? 2. So this turns into x equals 1 plus or minus 2i. It is 2 imaginary solutions, right? Okay, so then I need to go and include this with my solution set box all the way up at the top. 1 plus or minus 2i. How many solutions did I find? How many zeros? 3, right? Plus, minus, and -3. 3, and that's how many I should have. Matches my degree. Yes? Okay. So fun, isn't it? Ah, so so good. Like uses up everything. You guys are gonna use up all your brain power in here. I hope you don't have anything too serious 7th period. Okay, so let's look at number 4. 1, 2, 3, 4, 5. 5 terms. Can I even try to factor this? No. So what should we do? Put into the calculator. Let's look for some zeros, okay? And if you guys see more than 1 0, let's grab them all, all right? So let's put this into the calculator. Just make sure you don't mess up when you guys are putting this in. Take your time or go back and look at what you put into the calculator. And everyone should be doing this. All right, so look at this. It looks like we have a nice 0 at what number? -1, right? The other one looks like it's at 1/2, but you know what? I'm not sure, so I'm not going to do that. Let me go and check the graph. Yeah. -1 is a 0, okay? So that's the only one that I can get from this graph. Does that make sense? All right. So I'm going to draw my solution set up here. I'm going to put -1. That's my first one. Let's take that and do what? Thank you, synthetic. Let's see, 4, 3, 2, 1, constant. Good, everybody is there. Uh-huh. Oh, this one? Oh, here? Okay, so the first one always just comes down, right? And then you take these guys and you have to multiply. So -1 times 2 gives me that one. Okay. I'm sorry, if you missed this lesson, you want me to say what I'm doing? Yeah. Let me know. Okay, ask now. Will, do you get? Yeah. Okay. Yeah. Yeah. Okay. You know what? When I was doing this right now, I had to think about it for a second. It's really easy to make mistakes with this, especially with all the 1s and 2s and the negatives. Okay. So don't rush. All right. So the last one is R C X x squared and x cubed. Yes? So I have 2x cubed minus 1x squared plus 2x minus 1 equals 0. All right, so I'm going to show you guys something here, okay? Jaden, you ready for this? So if I look at this, I have 1, 2, 3, 4 terms. This is another one of those. It's not a quadratic yet, but I know I can factor when I have 4 terms, right? But just a little, this is kind of like what I think when I think about whether I can factor by grouping. I look at the coefficients. 2, -1, 2, -1. You know what? This may be factorable, right? Because there's a pattern there. So should we try it? Can we divide it in half and factor it and see if this works? Okay. On the left-hand side, my GCF is, yeah, x squared. So let's take that out of everything. On the right-hand side, my GCF is can only be 1, right? Oh, so this works. So 2x minus 1 and x squared plus 1 equals 0. Okay? You know, I can't say that that trick always works, but if you see a pattern there, you know what, it most likely it will. Okay? Especially with the type of problems that we'll give you guys. Okay? All right. So now, oh, it's so good. It's all set up for me to solve, right? 2x minus 1 equals 0. So what is x? Yeah, 1/2. Just like we thought when we eyeballed that other 0, right? But now we have confirmation. Okay, so we're not just guessing. And then how about this? X squared plus 1 equals 0. Yeah, thank you. But just I? Thank you. Because remember, when we draw the square root, we have to put plus or minus. And square root of -1, well, that is the definition of I, right? All right, so we have plus or minus I, and we have 1/2, so I'm going to go and add it here. So how many solutions do I have in my solution set? 1, 2, 3, 4. Yep. And is that how many I should have? Yes. Okay. All right. Pretty good? Okay. Let's try the next one. Wow. Okay. This is crazy. All right. First step. Where do we put this? Calculator. Let's do it. Let's put in the calculator and see if we can get some zeros. And be careful when you put this into the calculator because that's a pretty long equation there. Everyone put it into the calculator. Okay, everybody should be putting this into the calculator because I don't want you to go home and do your homework and say, oh, I don't know what to do. So when we graph this, let's see. Is that it?
No, there's more. Right there.
Oh, okay. All right. Okay, so does your graph look like this? Does it look crazy? Oh my goodness. All right.
Even called it.
So 1, 2, 3, 4. Looks like 4 is a 0, right? You see this little thing? This little, like, I don't know, little mountain peak thing? And it looks like it hits the graph at -1, right? Okay, let's go see if -1 and 4 are both zeros. -1 is a 0. And what else? 4 is a 0. I'm going to tell you guys something, though. Remember when we talked about double roots? I said that double roots bounce off of the x-axis, right? It doesn't cut through it. So if you look at this -1, doesn't this graph bounce off of the -1? It just doesn't bounce up. It like bounces back down, right? That means there's a double root there. It means we have 2 -1s. And that's so cool. So now we have 1, 2, 3 zeros that we got just from the graph. Does that make sense? Okay, so let's go and write our solution set. I'm going to write -1, -1, and 4. Because those are all of the ones that I got from the calculator just now, right? How many should we have? 5. So we only need to find 2 more. Oh, that's great. Okay. I'm going to show you what to do when we can get more than one from the calculator. So good. You know you have to get a 0 and use synthetic division, right? So let's use this first one, -1, and let's do synthetic division here. Let's see, 5, 4, 3, 2, 1, constant. Good. Okay. All right, so let's do this. First one comes down, you multiply, and you go diagonally, and then you add when you go down. Then you multiply, and then you add, multiply, and then you add, multiply, then you add, multiply, and then you add, and you should get 0, yes? Okay, so, all right, I use -1, right? Is there any way that this is down to an x squared? No, right? Even if I don't write it all out. RC, x, x squared, x cubed, x to the 4th. No, still too much, right? So don't even rewrite it here. Didn't you get another 0 from the calculator? Now let's do it again and use that second 0, okay? So if I were you, I would just extend it here. Use those same numbers and put -1. Oh, so good. We're going to get through this in like no time. Huh? Why did I do this? Because every time I can do synthetic division with a 0 that I can get from the graph, it brings my polynomial down 1 degree. So you see how we started with x to the 5th? Since I found 3 zeros on the calculator, the first time I do synthetic division, it brought it down to x to the 4th. Yeah? I still can't factor it. I can't do the quadratic formula. I can't do completing the square, right? So I'm going to take my second 0 that I got from the calculator, and I'm going to do synthetic division again, and then it'll bring it down to x cubed. You see? Like, every single time that you can use synthetic division and bring it down, it makes it that much easier for you to solve. Okay? All right. Multiply, add, multiply, add, multiply. Oh, did I do it wrong? Okay. Add, multiply, add, and 0, which I should be getting because these are zeros, right? Okay. And you know what? I know I can factor this. Because look, 1, 4, 25, and 0. 25, 1, 4, right? But no, I'm not going to factor it here because I have a 4. So I'm going to do synthetic division again with the 4 because why not, right? Synthetic division is just so much easier. Do you guys see what I'm doing? Is anyone confused about what's happening right now? Okay, all right. So bring down the first one. Multiply, add, multiply, add, multiply, and a 0 again, which it should be. Yeah. And so now I can do my R, C, X, and X squared. because I don't have any more zeros from the graph that I can use to do synthetic division. Does that make sense? Okay. Okay, so here I'm going to rewrite this and say, all right, x squared plus 25 equals 0. Right? Because you don't have an x. So don't put plus 0x. That's just 0. That's nothing. Okay? So how do we solve for this x? Oh, no, not those. It's not plus. I mean, it's not minus.
You subtract.
Yeah, subtract the 25. X squared equals negative 25. And now what? Square root. Square root with a plus minus. So x equals plus or minus 5i. Good. Oh my goodness, so look at that. Those are the last two x-intercepts, or the two zeros that we needed, right? Which, those aren't x-intercepts, those are imaginary. Okay. Plus or minus 5i. So I can go up here and put plus or minus 5i. And there we go. 1, 2. 1, 2, 3, 4, 5. 5 zeros. Right? It's not bad. And your calculator actually does a lot of the work for you. Yeah? Okay. All right, let's look at this one. All right, well, you know what? Let's make this equal to 0. So, you know, you could factor this, but since we're not using the factoring way, we're trying to use the synthetic division. What should we do? Yeah, you know, I mean, you could factor it because you could take out the GCFs, right? But you could also just graph this and see what you get for your zeros. What would you like to do? You want to do a GCF? Doesn't really matter. Calculator? Okay, put it in the calculator. See what we get. Why is it ugly? Okay, it is pretty ugly. But don't those look like double roots? Well, let's see. We know that 0 is definitely one of them, right? Let's see if negative 2 and positive 2 are. Yeah, negative 2 and positive 2. So we have negative 2, we have 0, and we have 2, right? We have negative 2, we have 0, and we have 2, right? So we have 3. You know, here's the thing. That graph made it seem like they were double roots, right? But how come it spilled over a little bit? Right? I don't know, right? So if you're unsure, because sometimes the calculator could make mistakes or the calculator is not very clear. I mean, the calculator already found 3 zeros for you. Can't we do synthetic division and just solve for the other 2? Yeah, so let's do that. So with this guy, then let's do negative 2. All right, you gotta be careful with this one because look, it starts from x to the 5th. Is there an x to the 4th? No, so you gotta remember 0 x to the 4th. 5, 4, 3. Is there an x squared? No, so you gotta remember to put in a 0x squared. X, is there a constant? No, so you gotta remember to put in a 0 for the constant as well. Okay? Mrs. R, we took a vote. We decided not to factor anything out and go straight to the calculator. 2, 0, negative 14, 0, 24, and 0. Yes? All right, which I love. You know what? Your 7 period, you may just want to do that. It keeps it consistent. 2. Does that multiply? Add 6, negative 6. Multiply, add, multiply, add, multiply, add. Right? That extra 0 was because I don't have a constant. Right? Don't forget about that 0. Yes. No, does not matter. So I just did the negative 2. So now, should we do 0?
No, it's just
Yeah.
so
No. You know why? Okay, so, all right. There's a little bit of confusion here. This 0, right, is from my constant 0. This polynomial ends with a 24x. Where's the regular plain old number? It's not there, so that's that 0. Okay? All right, well then, so the next one, yeah, we could do 0. Synthetic division with a 0, yeah.
would you skip the 0 and go straight to the 2, or
You could do 2. No?
you don't have to do the 0?
No, but sometimes you may need it to get it down to like x squared, but we'll do 0. Write down the first one, multiply, add, multiply, add, multiply. Well, multiply part is easy, right? Add, multiply, add, multiply, add. This is x to the 4th. This is x cubed. Right? We started with x to the 5th. The first time we did synthetic division, it brought it down to x to the 4th. The second time we did synthetic division, it brings it down to x to the 3rd. It brings it down 1 degree each time. Yeah? So now I did synthetic division with a negative 2 and with a 0. Now I just have the 2, right? So let's do that with the 2. Bring down the first one, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Yeah? Yeah. Oh, so you know what? Actually, okay, now let me clean this up. R, C, X, X squared. Ooh, hold on. Did I mess up somewhere? Where?
You're not supposed to include the remainders from the previous one.
Yeah, you
Oh my God, I'm sorry. Okay. Okay. Get rid of those. Okay, so the remainder, that one's gone. Here. I'm sorry. And then this one was gone, so then it's here. R, C, x squared. So lesson being, you see how easy it is to get confused when there are all those zeros. Don't bring the remainders down. Accidentally on purpose, yes. Sorry, guys. Okay, so now we have 2x squared. The x one is out, right? Minus 6 equals 0. Can I factor this? Yeah, well that's what it is. You can factor the 2 out, right? Or you could add the 6. Sure, let's do that. Add the 6. 2x squared equals 6. Divide by 2 first and then square root, okay? X squared equals 3. Square root comes with a, yes. So x equals plus or minus root 3. Plus or minus root 3. So that's 1, 2 more. How many zeros do we have altogether? 5. Is that how many we should have? Yes. Okay. All right. So we have 2 minutes. How do you guys feel about this? Are we okay? Oh, good. Great.